So guys, welcome to chapter 7. We have to create a new scene, and this time I like to talk about velocity field. So we'll take a tour about velocity field, how to manipulate fields using pyro and some VOP operation, and it will be useful to finalize our final project. And I'm talking about simple uh, nebula effects. So the main topics is the advention. So how to manipulate particle movement, particle velocity using the fields. So let's start a new scene, and will works out out of scale. Obviously, we are talking about uh, working in meters, and we are talking about nebula effects, so something really big. By the way, we need an emitter, and we can start with something like a sphere. It's not a problem. So let's say that we have a sphere, and that's the nebula emitter. Emitter spherical. Okay, so let's go to have a bigger scale. Let's say that this one is maybe 2 meters. So let's imagine that maybe we are talking about a really huge scaling, something like millions of kilometers and stuff like that. So we have not to take care about it because it's too big to be calculated in the right way. So we can have the scaling down to have the final result as we prefer. So let's go for a polygon mesh, and we can stay with maybe just a little bit higher detail to have something smoother. So as we done in the past, we can have particles over the surface and inside, because the nebula is essentially a volume. So let's go to convert this one to VDB from polygons. Okay, convert to VDB, and we need to convert as a gas, so we go for a fog. We can have a lower voxel size, so it will be a little bit more precise. Maybe we can go down there, so it's really defined, and we don't need anything more, so we can directly emit particles from there. So let's go for a pop network. We don't need to create from scratch, and let's say nebula particles. So the basic idea is that now we have the particles inside the volume. By the way, we are not going to create something complex. By the way, let's say that we are exporting just the particles, the pop object, this one. If you are going to rename this one, please remember that here you have to export something else because the naming is changed. So we can have points, and maybe we can try to have bigger points at the beginning. We don't need gravity because we are inside the space, so it is not needed. So actually we have essentially particles that are created step by step inside this volume. We don't need something like that. We need to have a lot of particles at the beginning, so we can essentially just have maybe let's say that we have, for the moment, let's try with 50,000 particles, maybe 500,000, and we say that we can have more and more particles by frame. The life expectancy can be also higher. It's not a problem because we don't need the particles to die. And then the next step is that, you know, we can have essentially this one animated. So we have a key at the first frame, and essentially maybe we can have just no more particles at the second frame. So particles are emitted just over the first frame. If you like, you can have, you know, the scaling. So you can say, for example, I like to have a higher number of particles. It takes a little bit to do it. Let's stop. Let's try with one. It is still too slow, I think. By the way, you know, we have different ways to do something like that. Let's go out. And let's try to, okay, now it works perfectly. So we have essentially this amount of particles at the beginning, and we can change it later if needed. So we have no movement, there is no animation and stuff like that. We can start preparing the animation using the advention, and we have a node. It is still a pop. It is called pop advent by volume. So we are going to use a volume to make the simulation. And you see, we need a SOP, or we need a connection. So we don't have it, so we have to create. Okay, so that's just a way to create something like that. So there are many ways, as always, for Houdini to create something like that. So we need to create a volume to generate the velocity field. So we can essentially convert this one as a sphere, as a bound, for example. So we can, let's say, use the bound node, and if we go inside the bound, it is creating the bounding box for our volume. If you like, you can have also a scaling. So let's say, for example, let's copy this one, and then there, paste relative, and then Ctrl C, Ctrl V, and we can do the same here. So copy parameter, and then paste relative, and then we can use the same Ctrl C and Ctrl V. So everything is linked. So if we go there, you see that essentially it is creating a bigger volume around our mesh. Something else, let's say that this one is the bounding box. Another way is to create essentially a box. Let's say manual bounding box. And we say the same. So let's say that this one is the stuff we see, and you see that's our box. Let's say scale 5, maybe 10, maybe 15. We have this volume. So that's essentially the same thing. And then we can convert everything to volume. So volume. So you can decide to have this one. Let's say generate volume fill. Here we are going to add the velocity, or we can do the same with the other. By the way, we have to set how it is working. So this one will accept vector fields because we are talking about velocity, and we can call it vel, that is a standard. So vel is the velocity. Inside the uniform sampling subdivision, that's the amount of subdivision to create the voxel inside. So you know, it is the same. If we say 10, it means that we have 10 subdivision over each axis. If we say 100, we have 100 subdivision. So it's more precise or less precise depending on the sampling subdivision. We are going to do the same with this one. So it is essentially the same thing. We are going to see how it looks in a few. If you like to see the field, we have some nodes inside Houdini. We have the volume trade. This one is able to show the trade. So it needs some points. So that's the velocity volume. So it needs to know which is the volume. and then it needs some points. You know, here we have some point. Sorry, we have some points there. By the way, it's not the way to play with. It is better to do something else. We can have, for example, the volume slice, and we have essentially needs to create this one. The volume slice is essentially a slice inside the volume, and you know, we can decide which is the plane, so we can decide to work over the x, y, y and z, and z and x. So we can see each plane, and we have the offset, so we can move it to see how it is working, and how it is taking care about the various level. We have to generate some fields, because actually if we go to see vel, there is nothing inside our volume, so we have to do something. And to do something like that, later we can connect this one if needed. Let's go to have something a little bit more clear, so something like that. Create volume slice. Okay. Volume trail. Let's say that that's vel field visualizer. Okay, so we need to create some information there. So we can operate inside the volume. To do something like that, we have the volume VOP. Volume VOP is essentially another vex operator as the point VOP and the others, so we can connect the stuff there, and then we go inside the others. And let's say manipulate vel fields. Okay, so let's say that this one is set to on, and we go there. Okay, so that's the field. Usually we work with the density, so you see that actually we have just the input as set as density and the output set as density. But we like to work on the velocity, so the first thing we need is to disconnect this one. So using the y-axis we can disconnect, and we need to export velocity, and to export velocity we need a node that is called bind export. Bind export needs to say which is the stuff we like to export, and that's the velocity, and we call it vel. And it is the data type is not float, it's a tree float, because it's a vector, because we have velocity x, velocity y, and velocity z, so we have the 3-axis velocity. We can manipulate the velocity. What I mean that if we go to pick a noise, let's see, for example, a turbo noise, and we get to connect the position to type, to position. Okay, and we get to export the input, and we say that this one is essentially a 3D noise. Okay, you see that we have the noise. We have the noise with a visualization, so it means that you see there it is moving, and we start to see the velocity. So let's go to change the roughness. You see that everything is step by step adapted to show you the velocity field you are creating, so you can visualize the noise essentially. For example, I can have more over one axis, less over the other axis, and let's say, for example, over this axis it is working like this one. So we'll take care about something later there, so to play a little bit with the fields. So that's our velocity field, and we can use it to manipulate stuff. So let's say that this one is the bounding box volume field. Okay, and this is the volume, the field visualizer, so we can call it field visualizer, and that's the color. Okay, let's go forward. Okay, next part, we have to take care about the velocity, so we can connect the field, because here we have the information about the field. You see that if we go to select this one, we have val x, val y, and val z, and you see that the proportion is 100, 100, 100, because we set 100 subdivision for each axis, and that's the resulting voxel size, so it's 0, 15. Let's connect this one to the second connection, and here in the pop advent, let's say that this one is the val field advention. Okay, let's say please use the second connection, and let's see what happened. It is moving really slow, but it is moving. So let's say, okay, it is 10 times faster, so it is using the speed found inside the velocity field, and then it is multiplying by 10. So you see that the particles are moving following the velocity field found inside the velocity field we created. You have different ways to manipulate stuff. We'll take care about it in a few, and I'm talking about the adventure type that is set to update force, update velocity, and update position. Let's move back to control the field. We can have back the visualizer. Okay, so let's move back to the visualizer, but we go to have the slice over the X. Okay, so now back there, let's say that we have back 1, 1, and 1, maybe 0, 5, 0, 5, and 0, 5, and let's go for 5 for the turbulence. By the way, go higher for the roughness, or maybe that's too much. Okay, so we should see the stuff moving in this way. So if we go back there, you see that it's moving as this field. You see, and that's working perfectly. Okay, so that's a really nice way to manipulate stuff. Obviously there we can do whatever we like. So if you like to do something as we done before with the anti-alias noise, you can do it. So you see we can do stuff like that, and we have to say that the output is 3D. Okay, so you see it is working perfectly. Let's say that the scaling is maybe just a little bit bigger. Okay, if we go there inside the pop field there, and let's say that the particles now are points, maybe a little bit more little, stuff like that. Okay, so you see how it is moving. It is really a fluid way to move, and that's really nice. Remember that we have the field there. Our field is essentially the space. So you know, when we are at the edges of this environment, it will have some strange behavior. So the best way is to have this one really, really big. So let's say in this case, you know, we have to work with a nebula effect, so we can go to have something really big. So you see that it's behaving in the right way all over. We have no problem with it. The stuff that is really nice about the anti-aliased noise is that, you know, this one can be used, this one is not useful, and you can do whatever you like. So for example, we can also imagine that we have something like that. So we have this noise, and the output is this one. So you see we are using two noises. Okay, so we can say, for example, that this one is lower, and we see more the other one, you see. So we have the possibility to do a lot of stuff. We can do stuff more complex than this one, so don't worry about it. So let's remove this one. Let's say that we are going to use still the anti-aliased noise, and remember that this one can be animated. So if you need it, remember that you can convert vector to vector 4, and we can have the position, we can have the time, and then we can go with this one. So now the noises, right, we have to say that the output is 3D. Now it is behaving with an animation too, so that's really more complex than before. And in this way, if you like, you know, it can be something similar to a galaxy, you know, because it's behaving in a really complex way. You see that we have this kind of deformation, we can have this simulation, and then we can, for example, use just one frame of this simulation, and that's all. So let's go back inside the particles, and let's see what happens if we go there inside the animation, and sorry, we pick the number there, and we say that we have 5 million particles. Now we have a lot of more particles than before, but we'll be able to create something really nice. And something else that can be done is to start with something different. So let's say that we have this one. We have maybe a bigger scale over the x-axis, then we have a mountain to have a deformation. So obviously this one needs to be connected there, and let's say turbulence, and this one can be a little bit bigger, but we go also with a bigger scale, and let's go with an higher number at the beginning. So you see that the particle starts with a different shape at the beginning, so we can manipulate a little bit how it is looking. If we go there and say please show just pixel, you see that that's really, really nice. And on the other side, let's see there, and maybe we can have a bigger scale. Okay, and maybe over the x-axis, let's say that is less, something like that. So now we have, let's go to the particles, we have a different deformation. So you see the basic shaping is controlled how we are managing the stuff inside the environment, inside the volume there. So what we can do there, remember that we can manipulate the stuff because it's essentially a particle system, so we can do whatever we like. So let's imagine to have a pop force and let's say random turbulence, and this one will be useful to create some kind of turbulence, let's say a really high turbulence. Let's set to off this one, let's go there, and let's say that we have less particles, so let's say 50,000. We need to see the points in a bigger way, so let's go back to points. Okay, so you see that's the noise. Now we'll take care about the scaling, so let's use a pop drag as we done before in the previous chapter. Let's call it air drag, and we can go higher. Let's try with 5. So we'll have drag inside the air, and we can take care about the pop force scaling to understand how it is looking. Let's see 10. Okay, you see that that's really big. Let's try with 6. Okay, let's try with 3. Okay, you see that's really a little bit little, and it's something we can add to the other effects. You see, okay, let's give us a little bit more turbulence. So if we are back also this one, we'll have both working all together. But I like to show you something. First of all, let's make it faster, and to do something like that, let's go lower, let's say maybe 50. Now we have less voxels, so it's a little bit faster than before, and I like to show you how it is working, because we have two different ways to manipulate stuff. So this one is with the update force. So it's something like, you know, another force that is manipulating particles. We have the possibility to say, okay, that's the velocity of the particles. So you see it is working in this way, and it means that if we have also the drag, you see that it's less visible than before, but it's more precise. And then we have the update position. In this way, it is essentially moving the particles to follow the noise position. And you know, we can have no animation there for the moment. So let's say that this one is the connection, and we have 3D and 3D. Let's go back there. And that's the way how it is working. Okay, if we go with velocity, it's similar to the position, and for us will be enough. And with force, you see it's supplying a force. So let's try to update velocity. It is blending with the other velocity we have there, so let's use both. So we have the drag. Let's see. And we have also this one. Obviously, you have to take care about the various velocity to find the best one. So it means that if we go back there and we say please do with 5 million particles, and we go back there and say okay, we're using pixel, and say let's go to frame 40. It takes a little bit to simulate, but you see that we are starting to have a really nice looking nebula effects. Now the problem is, let's go to save. We should need more particles, and it means that 5 million is not so much. So let's try with maybe 25 million particles. We have frame 80 to have this shape, so let's go back to 0 and then make to 80. So that's done. This one is really nice, so we can see something about the rendering with this one, and later we'll work on something more complex. So save, and let's take care about the lighting and the shading. Okay, let's go to see what happened when we try to render something like that. So there we can create a camera, and let's go for something like that, and Control S, and that's our camera. Let's create maybe a light. Okay, let's see where we have the light. Okay, we can move this light to trying to figure how it looks with a light inside the volume. Let's go in the render view, and we say to use the camera and render. Okay, so we are talking about sphere, obviously, so we need to take care about the rendering. So just to make something interesting, let's say that this light is magenta. Okay, then we go in the nebula, and in the render we go to have a material. We call it nebula, and then we have just to say that we use the point particles. We have no reflectivity for the moment, and back in the obj there we say to use this material, and then we can take care about the scaling as we done previously. So let's say 0.1. Okay, you see that we are starting to see something like a gas. So we can copy the slide, Ctrl C, Ctrl V, and stop this one. And we go to control, for example, this point there, and this one is, let's say, bluish, maybe something like that. Okay, let's go back in the render view, render, and we are trying to simulate the different colors around. It's just the beginning, because the color will be controlled later inside the particles too. So let's imagine that this one is set to off, and let's see that this one is bigger. Okay, let's try to have an higher energy. Okay, maybe the position is not so good because that's distant, you know. So let's say that we have something like that, maybe there inside the volume. It is simulating the energy inside the volume. So back there, and also we can add also stars later. So now it's too much. Or maybe we can essentially say that about the attenuation, we say that we have a ramp multiplier. Let's go with a lower distance, that's 1 meters, let's say 5 meters, and you know, we can say that we have more energy just at the beginning, and then it is falling down faster. So you see we have an higher energy in this area and less energy in the other areas, and we can do the same here. So we have a lot of energy there. Maybe we can go brighter too, and then we take care about the attenuation in the same way. Let's say that we have maybe less energy, that's 3 meters, and we go back to have the same lighting condition as we had in the other setup. So you see that this one is back there. sorry, it is falling down really faster than before. So you see we have a little bit of energy there, we have less energy there, and we can take care about this one with a lower energy. By the way, we have the same color, so step by step we can take care about something more interesting. And you know that we need for sure something about the points. We need a lot of points because we are using the particles to simulate something like that. By the way, we go back to a white color because we are going to simulate something like that. So we go for this one later, and now we go back to have some bluish color to simulate the gaseous energy. Okay, and save. To render this one, we can stay with this value and then we can stop there. And next step is to create something more interesting. What I mean is that if we have more particles, let's say that we go for inside the particles, we have at frame 80, and there we go to have maybe 100 millions particles. Then we go at frame 80, and you know we are talking about a lot of particles, so we can think about it to go with a file cache, so we can cache the particles. So file cache, sorry, that's wrong. File cache. Let's call it cache nebula. And then we say that right mouse button, delete. Let's say that we use until 80, load from disk, and then we save the simulation. Okay, so cache is done. So let's go to frame 80. Okay, you see that now we have a lot of particles. We need for sure still more particles because you know we need a lot of particles there. Just to know, we are talking about 4 million points. So that's how much particles we created in a single frame. Because you know we are talking about the amount of particles we set inside the pop network is for each second, so that's why we can need to have a little bit more time to create it. Or maybe we can also have some frames before to create the particles and then move forward. By the way, let's go to see how it looks in this way. Maybe it is a little bit slower at the beginning, but we can wait to see. Okay. Okay, let's try to do something with the lighting. So let's say that we have no attenuation for this one. You see that we have this kind of multiplying, and let's see if we do the same for this one. You see that we have all lighting moving inside the volume. By the way, let's go back to this kind of lighting condition, and I like to take a little bit less lighting at the beginning, so it will fall faster, and maybe we'll have more lighting distribution inside the volume, you know, something like that. And maybe let's try just to rise up the exposure. So we have a really high energy there, and let's go to scale down this one, 2.5, and maybe just a little bit better distribution all around. And we can do the same in the other configuration. So let's go to have something similar. So you see that we have more light there, and let's go with a higher intensity over there. And just to double check something about the scaling, let's go lower. I like to see how it looks when we have a lower scale. And inside the output, let's go for a higher general quality of rendering. So let's go for 0, 6 and 6. Okay, we need for sure a higher amount of particles. There we have a lot of particles, and it seems a little bit more gaseous than before, because, you know, for medium particles are not so much, but in this case there we have something interesting. Let's go back to check the scaling. I like to see what's going on when we have a lower scale. So you see, general look is more gaseous, but we need a lot of particles. So what's going on? We can have some additional light. So this one, Ctrl C, Ctrl V, and we can move it. We can have it there inside this area there, and this one can be another strange color. So let's go to see this render. Okay, you see that the lights are used to control how it looks. So you can go there and say, okay, let's use a different bluish color. Let's go for something like that. And maybe we can go darker. Okay, and for example, this light can be a little bit bigger about the ramp distance, so we can try to illuminate a bigger area. So you see that we are illuminating also this area. And again, talking about the color, we can make some experimental stuff like moving inside violet color. You see, for example, stuff like that. Let's see, with less, or maybe just a little bit more reddish color. And let's imagine that inside this gaseous stuff we can have some brighter. So let's say this one is 3 white, so this one is white. Okay, so it's in this area, but we got to have a smaller area for this kind of illumination, maybe 1.5, and we can go or something like that. So we have just an higher energy there, and then it is slowly moving away. And if you like, you can also use various colors, so you can create strange behavior in the lighting, because we can decide, for example, to have green, and we'll have a mixture about green and the other color, so we'll have a nice result together with the other color we had before. And we can do the same with the other, so we can pick, for example, this one, Ctrl C and stop, and let's go for Ctrl V, and this one can stay, for example, there, but we can have this one in a different position, so it's just essentially there in this gaseous area there. Okay, so you see we have lights in different kind of position, and for example the same Ctrl C Ctrl V can stay down there. So we go in this area, maybe behind, and the same will stay there inside the volume, and we can decide later which is the lighting condition with the color we like to use. So back in the render, okay, we have to take care about this kind of light. So the first one, this one, let's call this one top, so we know that this one is stay up there, and let's go for some kind of bluish or maybe violet color. And about the energy, we can go lower, so you see it's just one area as the others. Okay, then we have this area there, and we can go for something like this kind of color there, maybe with a little bit of bluish, or maybe because we are talking about gaseous stuff, so you can find the color you prefer. And this one is not bad. That's nice. Maybe it's better to have a higher blending inside the other color, so this one is blending together with the other, and we see that it's more little the area where we have a higher concentration about the energy. And the same for this one. So green is not nice, so we can go back to a violet color, and actually everything is mixing together in this way, so this light, it's really big, so we can remove this one, so delete selected points. Okay, and then let's say that we delete also this one, so we have something that is going from black to from white to black, and we go to 0 about the exposure, and we see that this one maybe it's a little bit bigger, so it's lighting entire area there. and maybe it is a little bit less powerful, also less. Then a nice idea will be to scatter lights around, just to have some nice kind of lighting around, you know. Okay, that's nice enough for the moment. So let's save, and maybe in the shader, let's go to the material. Let's say that we have a little bit of emission, and we go for a bluish color. Obviously that's too much. You see that we have a lot of nice structure around, so I like to have something like that. By the way, we have to go lower with this kind of emission. So I like to have something really low, just to know that we have a little bit of volume around. You see, we have this dark area in this way, and maybe to have a better result in the object, we can have, I know that this one it's not right, you know, because an environment light in this condition is not right, but we can use it to give us a nice lighting condition inside the volume. So also this one, let's try to find a nice color for it. So let's try with something like that, and we go low with the amount, so just a little bit around. Okay, so we see this kind of structure around the environment. You know, if you be able to add more light points, you will have something really nice. By the way, to do something like that, we can save this one, and we can pick one of this teeny lights. So let's stop, and this one maybe can be copied. So Control C, Control V, and you know, it is not so clear, but now we have less light there. So this one, let's move it in this area. So it's maybe there, but it is up. So back in the camera. Okay, and this one will be completely white. Let's try to have it completely white. And render view, we set the render, and then we take care about the lighting condition there. We try to make a really small area with some kind of lighting. Okay, obviously that's too much, because you see it's creating too much energy there. We can see the lighting condition. It's really nice, but it is still too big. So we have to decide something. First of all, the area. Now it's just 1 meter, so you see it's going to have coloring just in this area. Then we have to decide which is the color that is applied. Let's try to have a different coloring, like a different gas inside our scene. Let's go for something in between the green and the violet. Okay, let's go low with the energy, so it's just a little addiction, so then we can try to rise up the area. So it seems like the gas are changing their color in this area, you know. That's nice. Okay, so save. Then now we can try something. Okay, so the next idea is that let's see what happens if we have, for example, 10 times this amount of particles, because we're still not so much particles, so we can try to do something like that. So let's say stop and move inside the simulation there. So let's go at frame 1. So it needs to cook this operator. And we'll have a lot of particles for sure at the beginning. Sorry. The idea is that we can see how much particles we have there. So let's use this one. So we are talking about, if I remember, 100 million, so it's a lot of particles, but we need more. So for example, we can try to have more particles because we are going to emit more particles during the simulation. And to do something like that, you see that there we have this this key is set to frame 2, so it's going to change essentially at the same time. So it's something like having particles and then we have no more particles. So yeah, the crash before. So let's go to create something more simple. Let's say that we have 100,000 particles in 1 second. Okay, and then we go inside the source and we use the scale points. So in this way we can have a higher amount of particles step by step, just rising up this value. So let's go to pixel. It is still obviously low. Let's go to 0.5, but it will be faster than using the other way. And you see that step by step we have more chaos, so it can become really chaotic. That's really nice. So let's go back to this setup and let's say that we go for 0.1. So it will be a huge number of particles. Let's go back to see how much particles we have. 2 million, so we have half particles than before. If we like to double, we have to go to 0.05. Let's try 0.25. So we'll have a huge amount of particles, but again, please remember that we are talking about not so much particles because we are trying to achieve a gaseous look, so we need a lot of small particles. Okay, it's done. Let's go to see how much particles we have now. Sorry. Yes. Okay. And we have 8 million particles. So we have double particles than before. It is still not so much. So let's go to double again. So let's go for 1 to 5. Okay, that's done. Go back there and let's see how much particles we have. And we should have, essentially double particles. So we have 70 million particles. Now we should simulate until frame 80 because we have to see how it works. So let's go to save to disk, and it will need a little bit of time to cook this simulation, but the particle generation is not so slow because we have all particles at the first frame. Okay, so it's done. So we can go there to say please load from the HD, and then we'll say to go at frame 80. So let's go there, frame 80. It will go to load, and that's the actual visualization. So let's go for rendering. So let's take this one as a snap and then a new render. Okay, you see that it's starting to be more like, you know, a gas. It needs still more particles, but you know, because the thing is that it is working in a really nice way there, where we have a better structure, and it's working a little bit in a worse way there. By the way, we can take care about it in a few. So first thing to do, I like to have this one maybe with a lower energy. Let's try with 0.05. So it will be darker. I like to add this kind of light in there, so with dark area, but we have to take care about the material. So let's go in the nebula. Okay, let's take care about it in a new way. So let's say that we have no emission. So we should have everything dark there. So we have no emission, so everything about the shadows will be perfect. Okay. So the idea is that I really love this kind of structure we have there. So the problem is mainly where we have a more gaseous effects there, because we need still more particles to do something like that. By the way, I like to see what's going on when we try to have the particles smaller or bigger, so we can decide if we like to have something else. By the way, something we can take care about the rendering there. Let's go in the image, and let's say that the pixel filter is 3 about the Gaussian blur. So you see that the result is more blurry than before. Okay, we have, you know, it is something like having too much small particles there, and we should need more particles to have the right quality, because where we have more particles it is more gases. This one is really amazing because we have this kind of structure inside the galaxy, the nebula. By the way, let's go back to the objects, and we go just to see what's going on if we have smaller particles, and then we try to see with bigger particles. It was 0.025. Let's see with 0.015. Okay, it's you know, we are losing a little bit of structure around because particles are smaller, and maybe it can work in any way, maybe it doesn't work so fine in other ways. So let's try, for example, for 325, so a little bit bigger than before. Then we try to see what happens when we have different coloring for the particles, because actually we have all the particles with the same color. Let's see there. Obviously the structure are more visible than before, and that's really nice. But you know, again, we have the particles there also visible. But I have to say, I really love this kind of effects in some area where the structure are bigger and heavier. Okay, let's say that this one is saved and we stay with this setup for the moment. Later we'll take care about something different, but before we go with this one. So I like to show you some stuff. First of all, it's essentially the pop color. So inside our particles, let's say that this one is the nebula emitter. So nebula emitter. Okay, here we have the cacher, and here we have the nebula particles. Oh, sorry. Okay, so let's go inside this one. Obviously it needs to be calculated again, because so let's go at frame at the beginning. Okay, and inside the particles, let's try with a lower amount of particles. So let's say that we can stay with 0.125, so more particles than before, but we got to add a ramp. So pop color, particles coloring, and we got to use a ramp, and we are going not to use the age, but we got to use the speed. So particles are based on the speed, so you see that we have to go at frame 80 to see how it is looking. So let's go at frame 80. Obviously the particle amount will be lower than before. We are going to remove also the grid in a few. Okay, so we have it. Let's remove the grid. And about the color, let's see, first of all, let's find the right speed, because this is the range, so we have to see entire color range to be sure that we are checking everything. So we should have the white 2, okay, maybe 2.5, okay, something like that. So we have the different speeds, so we have the different color there, so we can go there and say, okay, there we have something like that. It will be clear, okay, and then there we got to do something simple, but you have the possibility to do whatever you like. So for example, there we can say, okay, we have something greenish, and there we have something bluish, or maybe something like this blue, okay, and there we have again some different kind of bluish. We can have a color in the middle there, so maybe a dark red, really dark, but moving similar to the other color, and maybe just this one that is too much clear. It's the wrong one. No, it's not this one. So let's go back to this color. It is essentially this one, the middle one. So let's go for something, again, something violet. Okay. Let's try to see with a different ramping. Okay, so what it means that now we have this kind of color, so the material is using this color. Okay, so if we go there and we go back to the rendering, let's make a snap and render. So you see it is working in a different way, and that's due to the coloring we are creating inside the particles. So if we go inside the material, there we are saying if we have to use the color or we have not to use the color. Okay, so it is clear to understand how it is looking. Then we can go for the white, and then in this way you can take care about the coloring, about the galaxy, the structure based on the color you have there. So you can go back there and say let's change the color. So if you don't like too much this bluish, let's go for a natural color. We can make the change we like, because you have complete control over the color there. So if you like this kind of energy, you can do it. If you don't like this bluish, let's try to use a different color. You see that you have a lot of colors changes inside, because now we are using the color from the particles and the color from the lights. So everything is really more complex than before, you know, because it is based also over the other stuff. And you can do the same with the color we have there. So you can say, for example, this one, okay, it's this kind of, let's copy this value, and then you can say, let's try to go in this way. Or maybe we don't like it, so let's go with the green. And then you can see how the color are mixing together, our color and the color we add inside our lights. So it's really nice way to control how the stuff are looking. So let's say that we like this one. We need to cache everything again. By the way, you see that's how it looks. So it's obviously we need a higher density, but the coloring maybe is better than before. Okay, because it's more complex than before, and you can do obviously also something more complex there. It's not a problem. But if we save and let's go back at first frame. And other things, let's imagine this one is set to off. That's essentially a particle, so you can play with it as you prefer. So for example, if you like to use a point pop, let's go to select point pop, you can do it without any problem. So let's say nebula displays, we have this point pop. Let's go in the point pop, and here you can do whatever you like. It's up to you, you can do everything. So for example, we can say we like to have an add, we like to have an add noise, and we have this position, we have this noise, we connect there, and we have this new position. So you see that we have an additional turbulence inside. We say that we need a 3D output, so that's the new additional turbulence. If we go at frame 80, we'll see the particles at this frame with the structure we had before, and we'll have also the noise. And it's useful because if you like to make an animation using just a still frame from the simulation of particles, you can do it. You are free to do it, it's not a problem. So let's see what happened. That's without noise, that's with noise. So you see that we have this additional structure inside. You can decide how much it needs to be distorted. We can have more random noise, you see, or maybe we have a little bit less, but you see we can have more octave if needed, but you know we have a lot, so it's not so visible. Let's go to have a nicer look with a higher frequency. Let's go to 0.5, that's enough. And then we go lower just a little bit. Let's see with 0, 0.5, 0.2.5. Okay, just a little bit, you know. This additional effects is done later, so it means that it needs not to be simulated, and you can see the result just rendering the stuff. Okay, there is another thing we can do with the advention, and it is done using the pyro effects, so we can use the fluid dynamic to control something like that. And it can be done, and we'll do something like that on the next part. So in the next part we'll finalize our scene to see what we can do inside this one and how it can reach a better level of quality. So you see that's the result with the additional distortion. It can be nice because you know you will have an additional distortion all around. By the way, let's stop and let's go back to the first frame. Then we go to have the final amount of particles as we done before, maybe a little bit more too. So let's go inside there and we say to use maybe 0. Let's try with 0.85. So a huge amount of particles. I will simulate and cache the file so we can see together the result, just to have an idea about how many particles we can have and how the looks will change. Okay, so guys, it's done. You see we have a lot of particles, everything is cached, and we are using this one. So we go at frame 80, the last one that was cached. Okay, we have the final shape there. So that's the basic shape, and we can see how it works going in the render and render. Okay, it's rendering. Let's go to see, for example, this area. We see a lot of structure now. You see how the structure are dark, because obviously we have light just inside the volume. And then you see that the quality is really nice. Remember that that's just a basic approach to create some gaseous effects. What I mean is that, for example, we have still not so much particle, because we are talking about around 30 million particles, and that's not so much, but it is nice enough to start playing with these effects, you know. So you know that if you like, you can have this one, so you can connect to the bulb, and then we go to distort the bulb. Okay, by the way, let's go back to the scale there, and I like to see in this case if we have smaller particles how it looks. Okay, it is start. So in this way, you know, when we have some particles alone, volume will be less visible. So it means that we are able to see more structure and less the simple gas we have around, you know, because the small particles will be so small and will have no visibility. Okay, so we can make a test. Maybe we can do something still more little. Let's try with 0.01. Okay, so it means that, you know, their particles are less visible because they are alone, and when we have structure, particles are more visible. With particles so small, we can have, for example, more and more particles to achieve a nice result. You know that we can, for example, manage point, because now we are talking about points. That's the nice thing. So if we go there, you know that we are talking about points. So first of all, as you know, we can play, you see, with a pop without any kind of problem, because this one is able to distort a little bit more the entire simulation. And that's something else that can be done. You know that, for example, we have the point getter. The point getter is going to create some chaos inside the points. You see that in this way it is essentially really huge. Let's say that we go for a different seed, and we don't need to work on the normal. Let's go with a lower amount of chaos there. So let's see. So you can see there the position is a little bit different, a really small amount. So particles are really near the other, but you know, if we go there in the getter, let's try to move it a little bit more. We have a little bit of change. It means that, for example, we can say then let's use a merge, and we go to merge both. So, sorry. Okay, that's with just one particle. That's the result, you know. And then we go to connect this one. It is updating, and the idea is that there we have 25 million polygon particles, and there we have 50 million particles. If we go inside the render view, let's select just this area, and it starts again to be rendered. Okay, it's rendering. That's the result. Obviously, we can use an higher level of jittering to have more and more particles. So in this way, you can multiply the amount of particles without the needs to resimulate everything, or that's the simplest way to do something like that. So you can multiply the amount of particles in this way. It should work in a really nice way. So we've done a lot of things for the moment, so let's save. And again, you know that again you can pass this data to the Bob to have a little bit of more chaos inside the simulation. Let's go to select this node. So you see that you have a lot of more chaos inside. So I'd like maybe just to see what's going on when we have a different frame, just to see how it is looking when we have less dispersion. Because you know, the interesting thing is that, you know, in this area we have a really complex volume, and that's really nice. Here too we have a lot of volumes, but that's the area where we don't have a so nice looking volume, and that's because, you know, the particles are too small. Okay, too small, I mean about the density, because the amount of particles is too low. So what's going on when, for example, we are at frame 50? We should have a more precise structure. Okay, you see that obviously the density is higher. So if we go to render this area again, we should have something more dense. The color maybe is not so perfect because you know, we are working with the lights that are in the wrong position, because our frame is the frame 80. By the way, let's take care about it just to see what's going on. Okay, you see that's with more particles. It is more like a cloud. But again, where we have less particles, it is starting again to where it's not so nice. So stop back to frame 80 because it's the one we're going to use, and that's for the moment our result. So in the next part we'll see how to play with the pyro advention, and we'll take care about also having a better result with the rendering for this one. Okay, so guys, let's move forward for the next chapter.